Multiple current carrying wires 5. For each case below, determine the magnitude and direction of the B field at each point P. Now to do that, I've included here the equation that we've come to know and love about the magnitude of the B field at a radial distance r away from a current carrying wire that is carrying a current I. So there it is right there. And what we want to do is we want to use superposition for this case. Let's take each wire in turn. The magnetic field strength due to the wire on the left is going to be mu naught times I divided by 2 pi times 3r. That's how far away that wire is from point P, and that will be directed into the page by the Thumbkin twist and right hand rule. Then we need to consider the close wire. That will be mu naught I divided by 2 pi r. That will also be into the page. This looks to me like 1/6. That's what that fraction is, plus 1/2. They're both going in the same direction. So I believe that's going to be 2/3. 2 mu naught I over 3 pi r, and that's going to be directed into the page. Let's look at the next one. Here we have the first contribution is going to be mu naught times I divided by 2 pi times, once again, 3r, and that will be directed by the Thumbkin twist and right hand rule into the page. Then we take the other wire, mu naught times the current I. How far away is that? It's going to be 2 pi, simply r. Now, if you use your Thumbkin twist and right hand rule, the contribution from that wire will be out of the page. So you see we have a subtractive effect here. This looks to me to be 1/6. This looks to me to be 1/2. And because we have to subtract those, we're going to end up with 1/3, aren't we? Mu naught I 3 pi r. And who's going to win here? The 1/2 contribution is bigger. We're going to have a net out of the page. Feel free to stop the video and do these problems on your own here before I just charge through the answers. We're going to do the same sort of thing here. We have to use, though, this time 3 wires. So here we go. We'll use them 1 wire at a time. Mu naught. Now the first wire now has 2I for its current, and we're going to divide by 2 pi. And how far away is that from point P? It's 3r. And the contribution from that wire is going to be out of the page. The middle wire, mu naught, simply I this time, divided by 2 pi. And how far away is that one? It's only r. And that one is directed into the page. And then the wire on the right, we go mu naught. The current is 2I divided by 2 pi, and the distance away is r. And that contribution will be, if you use your Thumbkin twist and right hand rule, due to that current, it's going to be out of the page. So it looks like we have 2 of them that are out of the page and 1 of them that's into the page. Let's see how much we have here. I'm looking at 1 out of the page plus 1/3, so that's 4/3. And then we have a half that is in the page. 4/3 minus a half. That's going to be 5/6, isn't it? So let me write that under here. 5 mu naught I over 6 pi r. And who's going to win here? Out of the page wins. Like that. Moving right along. Same thing here. Same old, same old. Mu naught times that current, which is 4I, divided by 2 pi. How far away from the point in question? 3r. What's the direction? Out of the page. Middle wire, mu naught I divided by 2 pi. How far away? R. Direction? Out of the page. Wire on the right, mu naught I 2 pi. How far away? R. What direction? Into the page. Well, you know what? Those two cancel each other, don't they? Look at that. So I'm thinking that the answer for this case is going to be, what is that? 2/3? 2 mu naught I over 3 pi r out of the page. Two more. Again, stop the video if you want to do these on your own. Now these look a little bit different. There's definitely a very complicated pattern to the magnetic field lines of these two wires that are carrying currents. But the magnitude and the direction of the magnetic field at any particular point can be simply found by doing the superposition procedure that we have been doing up to this point. Let's take the vertical wire first. Mu naught times its current divided by 2 pi times how far away radially, 2d. And in what direction does that act? It acts into the page. Let's take the other wire now. Mu naught times that current, which is 2I, divided by 2 pi. How far away? We're only d this time. And in what direction is that? Using our thumbkin twist and right hand rule, that is also into the page. So these are simply additive, and it looks to me like I'm seeing a fraction of 1/2 here, and then this is 1, so that would be 5/4, wouldn't it? 5 mu naught I over 4 pi d, and that will, of course, then be directed into the page. Last one. Let's take the vertical wire first. Mu naught times the current, which is I, divided by 2 pi. How far away are we? 2d. What's the direction of that? The direction of that is going to be by the thumbkin twist and right hand rule into the page. What about the other wire? Mu naught, the current is 2I divided by 2 pi. How far away? Just d. And what's the direction of that magnetic field contribution? By the thumbkin twist and right hand rule. Put your thumb in the direction of the current and your fingers curl in the direction that the magnetic field lines are. And when we get to point P, look at my fingers are pointing towards us, which is indicated by the dot symbol. So we're going to have a subtractive effect here. These amounts are going to have to be subtracted from each other. I'm seeing this turns out to be 1, doesn't it? 2 and a 2, so that's 1, and this is 1/4, and we have to subtract, so that's going to be 3/4. 3 mu naught I over 4 pi d, and the bigger one is going to win. Who's bigger? Out of the page is bigger, because this one was 1, and that was 1/4. I think that's what you've got.